A very warm welcome, students. Today we will be learning another chapter in Karst topography. Today we will be studying about the depositional landforms of Karst topography. Karst topography is a combination of many unique features that make it distinctive, especially the dissolution of the limestone. Sinkholes, caves and underground rivers are a few of the depositional features that influence the Earth's surface. These features not only alter the geographical characteristics of the environment, but also impact biodiversity and hydrology. This prominence highlights the importance of studying the depositional landforms that form in the Karst topography, for they hold significant ecological and geological value. Objectives. After going through this module, you will be able to understand the following: the overview of Karst topography, deposition and karst, the resultant landforms, importance of the depositional landforms. Let's try and understand Karst topography. Karst topography is a unique geological landscape which is primarily formed through the dissolution of soluble rocks, particularly limestone and dolomite, over extended periods. Karst topography is a result of the reaction between soluble chemical rocks with slightly acidic water, often from precipitation, reacting to features such as sinkholes, caves and underground rivers. As the rock dissolves, it creates complex, interconnected networks of passages that significantly alter the landscape. In today's class, we will be focusing on the depositional features of karst topography which occur within the subterranean environments, revealing the dynamic interplay between erosion and depositional processes. Depositional landforms and their importance. Depositional landforms are key elements of karst landscapes, playing a significant role in both geological formation and ecological environments. These structures are developed through the accumulation of sediments, often linked to the dissolution of soluble rocks like the limestone. Their significance lies not only in the environmental beauty they uphold, but also lies in the fact that they can also serve as historical records which preserve evidence of past climate conditions. Present is the key to the past, holds true here. They can also be the conduits of paleontological, paleo-environmental and archaeological remnants, such as caves can trap surface materials and also safeguard them from erosion. This protective function highlights the information that is essential role of depositional landforms in preserving biodiversity and cultural heritage in the karst areas. The depositional features are also a result of interaction between surface water and subsurface water, which illustrates the dynamic processes that shape these regions. Therefore, recognizing the significance of depositional landforms is vital for the conservation and effective management of sensitive karst ecosystems. Overview of the karst processes. Karst processes are fundamentally shaped by the chemical weathering of soluble rocks, notably the limestone, through a series of hydrological interactions that lead to a distinctive landscape. Rainwater, which is acidic in nature, serves as the prime agent in the formation of karst topography. Rainwater, slightly acidic due to the absorbed carbon dioxide, infiltrates the soil. It begins to dissolve calcium carbonate, from the limestone, thus initiating the formation of various karst features. Over time, this dissolution results in the creation of sinkholes, underground streams, and extensive cave systems that characterize the karst topography. The interplay between surface water and groundwater is particularly crucial, as surface runoff can lead to the development of significant erosional features. Movement of groundwater facilitates deposition processes within the caves, which manifest as stunning stalactites and stalagmites. Let's understand the formation of karst topography. The formation of karst topography is a complex geological process primarily driven by the dissolution of soluble rocks, particularly limestone, due to acidic water. Rainwater absorbs carbon dioxide from the atmosphere. When it reaches the soil, it transforms into a weak carbonic acid, facilitating the erosion of limestone bedrock through a process known as chemical weathering. Chemical weathering is the primary denudational activity which leads to the development of distinct features such as sinkholes, caves, and underground rivers, stalactites, etc. in the karst landscapes. Over time, the continuous action of water enhances these features, resulting in intricate subsurface drainage systems and various surface forms such as limestone pavements. Geological conditions required for karst development. Karst topography is developed in specific geological conditions, primarily in the presence of soluble rocks such as limestone, gypsum, or salt. When soluble rocks in extensive horizontal layers undergo chemical weathering processes, when they interact with slightly acidic water, typically derived from rainfall mixed with organic acids from decaying vegetation, leads to the formation of karst topography. The foremost important is the presence of soluble rock at or near the surface. These soluble rocks should be dense, highly jointed, and preferably thinly bedded. Permeability in the rocks is preferable, but mass permeability is not preferred. This interaction leads to a progressive dissolution of the rock, creating distinctive landforms such as sinkholes, dolines, and underground caverns. Role of water in erosion and deposition. Water is pivotal for the erosion and deposition processes to take place, which shape the distinctive features of karst topography. Water is the primary agent. It percolates through the fissures in the soluble limestone. It facilitates chemical weathering and also transports sediment, leading to the creation of dramatic geological formations such as sinkholes, caves, and underground streams. The interplay between dissolution and sediment dynamics culminates in notable depositional features including stalactites, stalagmites, which further enrich the subterranean landscape. The process leads to precipitation of minerals out of water and become fixed in place over time. In the chapter of movement of groundwater, we have analyzed and learnt the dynamics involved. The karst topography deals with surface and subterranean or groundwater and leads to marvelous landscapes.